Good afternoon, everyone. Thanks for coming along to my session today. The session is called, What if DevOps was really simple? I wrote this title. I hate it because I hate it when people say, oh, it's really simple to do this thing. It's really simple to do that thing, because I'm usually struggling with the thing that they're talking about. So I don't want to be told it's simple. But I'm hoping today to give you a way to solve some problems that hopefully are useful. You might be doing some of them already. That's cool. Maybe I can fill some gaps. Or maybe you've nailed it, and this is going to be super boring, and I'm really sorry. So that's what we're going to talk about today, and we're going to do it through the medium of 8-bit computer graphics, right? So this is the quick overview of what we're going to go through. We're going to talk about the game over death spiral. That's where we're going to start. And then we're going to look at 4 things that we can do to not just stop that spiral, but to reverse it, make it a positive thing. After that, I'm going to explain why those things work, what the magic source is, because if we understand the magic, we can then make other decisions that align with that magic. It's like important to know why they work. And then after that, we're going to do some Q&A. So when you're sat there thinking, what's he talking about? You can actually ask me at the end if I've not made something clear, or if you think something's really weird and want to challenge it, that's cool too. So let's start by talking about the game over spiral. You can see here, I've broken my spaceship. That's usually what happens to me when I play computer games. And this is quite a common problem, and we see it all the time. I've been working with an organization called DORA, who have done over a decade of research about software delivery, and we find this all the time. And it looks like this. You can see it's got orange flames, so we know it's bad. I actually should have animated these to make it more GeoCities. That would have been quite cool. But the spiral works like this. We deliver very slowly, usually because of history in our organizations. Because we're not delivering very often, our batch size increases. We're changing more stuff between each release. And changes are a bit like radioactive material. If you store too much of it in one place, it tends to spontaneously explode. So when we create these large batches, we're basically creating a software version that's going to explode when we try and put that version live. And then because this batch size and infrequent deployments cause these big blow-ups, we then lose our trust with the rest of the organization. They think that we don't know how to do our jobs. And that means they then bring in bureaucracy, right? You can't be trusted to do deployments. They always go wrong. So here are some procedures you have to follow. And now you need additional signatures. And suddenly there's someone with a clipboard going around and speaking to the CFO to get a signature before you can deploy. And you're like, what's happened here? How has this gone so wrong? And it's because of these other items, right? It's coming back round. And the problem is, and we found this in the research, when you actually put in all of that bureaucracy to try and make deployments not fail anymore, they fail even more, right? It defeats the whole purpose of those controls, because it just makes us fail even harder every time we try and do a deployment. So this is why it's called the game over spiral, because each element is amplifying all of the negativity, and it just keeps going round and round in a circle until either you leave because you've had enough of it, or the company leaves because it's run out of money. So this is the problem that we're going to be trying to solve with our 4 things today. Now, there are already answers to this. If you want to solve the game over spiral, there's over 10 years of research in the State of DevOps report, and we've got models that show all of the things that you can do. This is just one of the models. There have been different versions of it over the years, all with good suggestions in, but you're probably looking at it and you're thinking, there's a lot of stuff on this list. How are we supposed to know where to start? So that's what this session's about. 4 things that you can do that are going to help start that reverse. So if any of that death spiral was familiar, I have answers for you right now. It's just 4 things. Super easy, right? 4-ish things. So when we look at them, they do break down into some sub-items, but if I said it's 10 things, no one would come. So it's going to be about 4 things. So let's start with them now. We're going to explore them all through a medium of games. So we have here a little character running around a maze, shooting creatures, and sometimes shooting food, which you're not supposed to do. Does anyone know what this game is? Gauntlet, correct answer. So Gauntlet's special because you can have 4 players, and each player plays a different kind of character. So you can have a warrior, a Valkyrie, an elf, and a wizard. And the reason this is cool is because that's a really diverse team, right? They have all the skills they need to defeat these dungeons. So the lesson that we're going to take from Gauntlet is our teams need to be mission-driven and user-centric, but they also need to have all of the skills that you need to get your change from your machine through to production. We don't want to hand over to a separate team to do our testing. We don't want to hand over to a separate team to do our deployment. This is where communication breaks down. It's where queues happen. So we would like a Gauntlet team that can defeat the whole dungeon. So that's the first one. We're now going to look at the next game, and it's going to be the same thing. So this one's slightly different. This one's in 3D. Wow. And there's a great big machine here, and a little character wearing a kind of headband. Looks like he's in an 80s rock band. Does anyone know what this game is? Metal Gear? Yeah, this is Metal Gear Solid. The machine is called Metal Gear Rex. And this is right at the end of the game. It's the big boss level. When I first played this game, I was like trying to hide behind things and take cover and then attack this giant machine. And every time I tried to do this, I just kept on getting defeated, right? Could not get over this boss level. It turns out, spoiler alert, if you just run straight towards it, it can't actually point its guns at you because you're too close, right? Who knew? So it's actually really easy once you know the trick. It's got a little tail laser, but you can avoid that. So this one is a boss level, okay? We want to avoid a boss level. That's the lesson from this game. So instead of creating a boss level by saving up all of our changes to deploy at once, we're going to work in small batches, right? Going to integrate our code frequently into the main branch. If we need to hide it, we can hide it. We can use feature toggles, or we can use keystoning, where you kind of build the non-visible parts first, and then only put in the visible part of your users when you're ready to show it to them. Or you might build it side by side. If you've got a screen that shows a list of chats that you've had with customers, you might develop a new screen alongside it. You don't show it to them initially. When you think it's kind of ready for people, you can give them a little link and say, go and play with the new screen. Then you can swap it out, right? Show them the new one, but give them a link back to the old one. And then if people are clicking on that link, you've missed something. Right? Why are they going back to the old screen, right? Have we forgotten to bring something over into the new screen? So there's lots of ways of hiding your work as you go. So get it into your main branch, deploy it, right? Don't need to show it straight away, but we do need to keep deploying it. We don't want to build up to a boss level change. To do that, we need lots of automated feedback. We need tests, we need security scanners, we need all kinds of stuff. And crucially, when we get feedback from those things, we need to act on it with a priority. So if I'm developing a feature, but the build is broken, well, the build is actually more important than my feature right now. So I'll prioritize fixing that. If I've got tests failing, they're more important, so I'll prioritize fixing those. The longer we leave things broken, the worse everything gets. So that's our second game, the boss level. Okay, slightly more modern now. Not necessarily up to date, but more modern. Here we've got looks like a raccoon rabbit. It's called a lombax. And it's got a little backpack, which is actually a tiny robot. Does anyone know what this game is? Yes, Ratchet and Clank, correct answer. This is the first version. There's lots of people saying bad things about the first version, but you get the idea. These two characters are trying to save the world with their unique skill sets. Sometimes you need the little robot to do things that you can't get to as a lombax. And the lesson from this game is that we want to use good robots. So we want to use the right kinds of automation. So we don't want to be checking coding style manually. We want that to be automated with our linting. We don't want to be running a command to do a build. That should just be automated. And our deployments should be automated because those are the things that most often go wrong. It's why people stop trusting us because we forgot a step every time we did a deployment or we accidentally missed a flag off of a command. That just needs to be automated, so it's not a problem anymore. And that extends to loads of other things, right? I don't want to put every kind of automation you could do on here, but like if you're doing something and it kind of feels boring and it goes wrong, it's probably something that should be automated, okay? Make it repeatable, make it reliable. That's our lesson from Ratchet and Clank. Okay, super old school now. We basically have two rectangular white things knocking a small square white thing around. And I imagine most people know what this game is. Any guesses? Pong, correct. You'll notice in this demo of Pong, the way you controlled it was with a dial. That was all you had on your controller. You just like move a dial. And it's almost impossible to even get your paddle to the right place in the early versions of this. But this version of the game, where you're trying to beat your opponent, isn't the most fun version. The more fun version is who can do the longest rally, right? So you just get two friends, and you say, who can actually keep this game going the longest, right, without actually losing points? And in order to do that, you both need to react really quickly to each other. And if you're super advanced at this, you end up lining up your paddles so you don't even need to touch the controller anymore because it just bounces back and forth between the paddles. It's like, yes, easy. And then you've just won. The lesson we're taking from Pong is responsive code review, right? Reacting quickly to the people on your team. Ideally, code review happens in real time because if I'm working on a change, we've probably decided that this is the most important piece of work. That's why it got prioritized and came to me as a developer. So why would we then put that in a queue and just stop working on it and then pick up a less important feature and start working on that one? But that's kind of the decision that we often make when we queue up code reviews. So there are ways that we can make this real time by pairing or doing ensemble programming so that we've kind of already decided that we're all happy with the change. If we're not going to do it real time, there's something that we need to prioritize. So we need to make sure people aren't waiting many, many hours or even days for a code review. We kind of want to process them really quickly. And we also want to make sure everyone gets the same SLA. I worked in one team where if you sat next to the person who did code reviews, you got them almost real time. And then the further you got away, the more desks you were away from the code reviewer, the longer your code reviews took. Because you couldn't just lean across and go, can you look at my code review? Thanks. And it meant that you had developers who were working in real time and developers that were working with a day's lag. And you kind of have a choice as a developer. Do I just start working on something else and just add more things into the queue? Or do I just, I've got a cool book that I want to read? I don't know, right? It's like, what do you do when you're waiting for a code review? So we want to make sure that our code reviews happen as close to real time as possible. Otherwise, why we're working on that feature, right? We don't make them just to kind of put in a drawer. We make them because we want to get them to users. So Pong is all about responsive code review. So that's about 4-ish things that we've gone through there. And we should probably talk about why those things work. So what is the reason these 4 things result in something better than that game over spiral? And the magic behind it is quite simple. Now, you may notice I've used the same arrows in this diagram, but I color them in green. That's because this is now a positively reinforcing loop. So now we can deliver our changes often instead of infrequently. And that means there are fewer changes each time we're doing a deployment. So there's less radioactive material all jammed together. So that's good. And that means our deployments don't go wrong every time, which means people start thinking, they know what they're doing. These people can deploy software and they're professionals. And then we can go to them and say, you know that kind of bureaucratic stuff we've got? Can we remove some of that? So you'll often find lots of checks and balances and deployment freezes and signatures and entire systems of service management have been put around deployments because they're going wrong. Well, when you've got enough balance in your trust fund, that's when you say, let's remove one piece. When you do that, it actually makes it easier to deploy even more often, which brings your batch size even smaller, right? So it keeps going around and it keeps getting more and more positive. Now, you may want to deploy every tiny change. You may be in a position where you want to do that. You might not want to push that amount of change all the way to your customers. I know that I prefer not to have to keep updating software that's installed on my machine every 3 hours, right? So there are some reasons you might not want to go to multiple deployments a day, but you want to be always deployable. You know at any moment if a version was needed, you could deploy it. And if you found a critical problem in your application, you know that you can get that fixed and deployed to production with minimal fuss, minimal time. And that's what this deployability is all about, even if you choose to kind of hold it back from just like every single change going through to production. So this is the magic behind why those 4 things actually work. Okay, so quick reminder of the 4 things. We have Gauntlet, which is about these cross-functional, multi-skilled teams, right? We're reducing the number of dependencies the team has. If there is a dependency, we design it well. If you've heard of team topologies, this is a really good way to design your teams to either remove dependencies, automate those dependencies function really well by deciding whether that relationship is a service or a platform or whatever. We then have the no boss level. So this is from the Metal Gear Rex example. We don't want to build up the amount of change that means that it's hard to win every time we do a deployment. Okay, we want to make it easy to win every time. We then have Ratchet and Clank. That reminds us about the automation. And that's super important because automation is very good at remembering all of the steps in the right order every single time. And then we have Pong, which is reminding us that it's no good having this amazing pipeline if you then sit on code reviews for like 3 days. Okay, it's like that's a real waste. Okay, so the final step now. This is questions and answers. So we're definitely going to have some questions. I may not have all the answers. And I will put up a little slide. If we don't have time to get to your question, you can stalk me online and you can ask me. You can also come to the Octopus Deploy booth after the session and ask questions there. But hopefully, I can answer some of them now. We have a few minutes. So if you put your hand up, they will be able to find you with a little microphone so I can hear the question.
Really good talk. Just wanted to ask for quicker pull requests and reviews. Do you have any tricks to encourage that? Or any, it can be quite a big thing in one of my teams. It can sometimes take days to get them through. We might have a PR checklist, all that sort of stuff. I know we're trying to use AI more and more. Do you have any particular tricks you would encourage?
Yeah, so you're not alone, okay? The problem of code reviews, we've studied this in the state of DevOps research. We've studied it in the state of GitOps research. Keeps coming up that code reviews are super slow. And it can actually be the constraining factor for your entire pipeline. It's quite common for code review to be the problem. So part 1 is back to that automation. Remove a whole bunch of tasks from the code review about coding style, security scanning, things like that. Get linting tools to do that for you. So now the code review is smaller. So that's the first thing. The second thing is small batches really help. Okay, I think if I get a code review and someone's changed one file, I'm like, boom, I'm on that. Yes, I can see the whole change really easily. If it's 100 files with 10 lines changed in each one, either I'm just going to like not do it, hope someone else has to pick that one up, or you end up doing probably what's worse, which is just you go, it's probably fine. I don't want to read all of that, so I'm just going to accept it. So small batches. And then the third thing is, it's like team culture, right? We kind of have to agree that if we have something that's ready, it's important for us to do the code review. And that's sometimes difficult. Sometimes code reviews aren't celebrated. They're not seen as being proper work and you don't get credit for it. If you're a boss in the room, like call out code reviews that are being done quickly and make it clear that that is something that you want and that you like to encourage that behavior. So hopefully one of those 3 will help a bit. All of them together should definitely help. Cool, thank you for the question. we have a microphone winging its way over.
Hi, Steve, and great talk, and love the gaming in there as well. You mentioned, obviously, the importance of developing a cross-functional team with all the skills required to get it done. How, across your team, do you currently determine who has the right skills and upskill them quickly and effectively?
Yes, so the way that I typically manage this is I create a map of the skills that I need. So pretty much it looks like a deployment pipeline in the middle. So we've kind of got the writing the code part, the testing part, the kind of builds area, the deployments area, monitoring. We kind of have that out there. And then we kind of build the depth in what's needed. And then we encourage people as they're progressing in their career to go wider, pick things that interest them. Who's going to be interested in databases and maintenance plans? Who's going to be interested in deployment automation? And then start building those skills. So it's like a general career map that everyone can use. And then as a team leader, the job is to overlay what everyone has got in your team to see where you've got weak spots. So, you know, if you kind of like imagine doing a heat map of all of those skills, and you're like, this one's nice and dark and we've got lots of skills there, but this one's a bit light, like, let's throw it out to the team. Who's interested in build servers? No one. Oh, okay. Who would be interested in build servers if it helps them develop their career? Oh, yeah. Okay, now I am. Okay, so it's like you need to know what those skills are and encourage people to step outside. And that works whether you've got, like, mostly teams have got like developers and testers, and maybe you've got someone who's got more of an infrastructure or ops background. So you've already got some coverage from that, but they will all be interested in finding out things outside of their direct role. And the team that I was running where we used this extensively, it was part of your career development that if you wanted to be mid-level, you had to be across at least 3 of these areas. If you wanted to be senior, you had to be across at least 5 of those areas, and so on. So, you know, all the way up. If you're a principal, you can cover the whole lot. Maybe not in absolute depth, but you had that wide knowledge. Yeah, great question.
Hi, I'm going to try and make it game related, but my nemesis, the bureaucratic person maintaining all the controls, how do I sort of win those early battles when things are really shaky? I've got some trust to try these new processes, but inevitably things go wrong.
Yeah.
And that my nemesis is ready to pounce, right? Ha, you've gone wrong. Let's put all the controls back. Let's rewind all the progress again. How do we defend against that?
So great question. Bureaucracy is a really difficult one because now we can't solve it with code, right? This is a cultural challenge in the organization. So usually I recommend that teams don't try and remove any bureaucracy on day one. First of all, you have to reverse some of that loop in order to prove that you can responsibly deploy without the CFO signing it off, right? Typically, monitoring on one end and deployment automation here are the 2 steps that will get you enough trust. If you do like 6 deployments and nothing blows up, that starts changing people's minds. And what you'll find is when the sign-offs don't mean anything, which they usually don't, and when the deployments are going well, which once you automate them, they should, the CFO doesn't want to be interrupted and have to do this sign-off. So look for the opportunities where people don't want to do it and you don't want them to do it, and eliminate those first. You'll then have the tougher challenge of trying to eliminate the sign-offs from people who feel their job depends on it. So, you know, if I'm a release manager, maybe I'm going to be quite sensitive to what this means for me if I'm no longer signing off on a deployment. And then you need to kind of work out how you bring them into this process, and like you give them the access to the deployment tool so they can press the button so they're still involved in it, right? You might need to do a little bit of networking to those people. They will be a lot more tightly clung on to those ideas. So yeah, but it does, the more times you can get around the positive spiral, the more likely you'll get rid of the bureaucracy. One of the teams I worked on where we did this, people were shedding it. We didn't even have to ask. The CTO was like, I don't want to be involved in deployments anymore. They're fine. I don't want to waste my time on it. And then the product owner went, oh, you can just deploy when you think it's ready, right? It was like cascading down. Suddenly no one wanted to be involved. It just worked. So yeah, hopefully that helps. We have 50 seconds if someone's got another question.
Hi, yeah. How do we deal with the fact that a lot of the C-suite level are pressuring us to use AI so essentially with GitHub we can use AI code creation, commit messages, PR reviews, deployments, close the loop. There's a lot of pressure to use that now because it's the buzzword, it's included in a lot of our subscriptions with GitHub. How do we manage that?
Yes, so how do we deal with the pressure of people wanting us to use AI? And this is an interesting problem because no top-down push in software delivery has ever been a good thing. It's never worked, okay? And this isn't to do with whether AI is useful or not useful. It's that top-downness that makes it such a big problem. When we do this to animals, we call it gavage, right? We want to inflate their livers so that we can sell them as a delicacy. And this is not a good way of running human teams. So what I would do in your situation is I would take that drive from leadership of everyone must use AI as permission to experiment and try things and find on the grassroots level what actually works for us in our team. So that pressure, you can kind of it's almost like use like a deflector shield. It's now permission for you to do stuff. And some of what you do might be full AI, you kind of try things out. We never have to write a commit message again. That might be a good thing. And some of it might be another form of automation, which is kind of what they're asking for. If they're like, use AI, that might also mean, oh, we could automate some more tests. And you can go back and say, we have increased our automation thanks to your amazing AI initiative. Thank you. So yeah, obviously, I'm a bit more of a punk. I'm happy to subvert systems, but be cautious if you're in an organization that doesn't reward that. Cool. Thank you so much, everyone. We've run out of time, but do come and find me if you didn't get a chance to ask one of your questions. I love talking about this stuff. And thank you very much.